Welcome to video number 78 of the channel Chemphilic, and video number 78 is the 20th episode of Chemical Thermodynamics. Topic of this 20th episode of Chemical Thermodynamics is pressure volume and pressure temperature relation in adiabatic reversible process. So let's start. In my last video, we have derived the relation between temperature and volume in adiabatic reversible process, and that relation was T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. This relation already we have derived in my last video. So now we have to derive the relation between pressure and volume in adiabatic reversible process. We'll start from this relation. So let's write not pressure and volume. Yes, pressure and volume only. We'll do it first. We'll start from this relation. So T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. Now we have to derive the relation between pressure and volume. So this temperature we have to replace in terms of pressure and volume. So from this equation we can write T1 by T2 is equal to V2 to the power gamma minus 1 divided by V1 to the power gamma minus 1. Now for ideal gas, we know that P1 V1 by T1 is equal to P2 V2 by T2. So T1 by T2, therefore from here T1 by T2, then that will be P1 V1 divided by P2 V2. So here I can write P1 V1 by P2 V2 is equal to V2 to the power gamma minus 1, then V1 to the power gamma minus 1. Then pressure part I'll keep it one side, volume I'll take it in other side. So P1 by P2 will be is equal to this V2 gamma minus 1 divided by V1 gamma minus 1. Then this cross multiplication, V1 will come here and V2 will go there. Okay. Now from here we can write P1 by P2 is equal to, this bases are same, so powers will be added up. That means gamma minus 1 plus 1. So V2 to the power gamma. Similarly here also V1 gamma minus 1 plus 1. So V1 to the power gamma. So from this what we can write, P1 V1 to the power gamma is equal to P2 V2 to the power gamma, or we can write that PV to the power gamma is constant. This is the relation between pressure and volume in adiabatic reversible process, that is expansion or compression. Okay. Now let's derive the relation between temperature and pressure in adiabatic reversible process. Okay, so we'll write relation between temperature and pressure in adiabatic reversible process. Okay. So once again we'll start from the relation, that is T1 V1 to the power gamma minus 1 is equal to T2 V2 to the power gamma minus 1. This is the relation between temperature and volume. Now we need the relation between temperature and pressure. So volume will be replaced in terms of temperature and pressure. So what we can write? V1 gamma minus 1 divided by V2 gamma minus 1 is equal to T2 by T1. Now once again, for ideal gas, P1 V1 by T1 is equal to P2 V2 by T2. So V1 by V2 from here, V1 by V2, that means P2 T1 and then P1 T2. So here I'll write, in place of V1 by V2, I'll write it as P2 T1 divided by P1 T2 to the power gamma minus 1 is equal to T2 by T1. So we can write it as P2 T1 to the power gamma minus 1, then P1 T2 to the power gamma minus 1 is equal to T2 by T1. Okay. Now what we'll do? Here also I have to write gamma minus 1. Here also P1 gamma minus 1. Okay, both are gamma minus 1, no? So temperature will take one side, pressure in one side. So P2 to the power gamma minus 1 divided by P1 to the power gamma minus 1 is equal to T2, then T2 to the power gamma minus 1 divided by T1 and T1 to the power gamma minus 1. So here also again base are same, powers will be added up. So plus 1 minus 1 will get cancelled. So from here P2 to the power gamma minus 1 divided by P1 to the power gamma minus 1 is equal to T2 to the power gamma and T1 to the power gamma. Okay. Now I'll write in the next page. So last what I got, we got it as P2 to the power gamma minus 1 divided by P1 to the power gamma minus 1. This is to the power gamma minus 1 is equal to T2 to the power gamma and then T1 to the power gamma. Okay. Now this one I can write it as, if I take it up, because P1 I have to take it to T1. So P1 to the power 1 minus gamma divided by P2 to the power 1 minus gamma is equal to T2 to the power gamma, T1 to the power gamma. Then what we can write? That P1 to the power 1 minus gamma into T1 to the power gamma is equal to P2 to the power 1 minus gamma into T2 to the power gamma. Okay. Then we can write like this, or we can write it as like this also. P1 to the power 1 minus gamma by gamma into T1 is equal to P2 1 minus gamma by gamma into T2. So this is the relation between this pressure and temperature in adiabatic reversible process. So what is the relation? That is P1 1 minus gamma, T1 gamma. That means from here what can I write? That this is Tp to the power 1 minus gamma by gamma, that is constant in adiabatic reversible process. So what are the relation? Relation between temperature and volume, that relation is Tv to the power gamma minus 1 is constant. Now relation between pressure and volume, that relation is Pv to the power gamma is constant. And relation between pressure and temperature, that relation is Tp to the power 1 minus gamma by gamma, that is constant. So temperature volume relation, this is pressure volume relation, and this is pressure temperature relation. That relation is this one, this is this one, and this is this one. These are the relation between temperature volume or pressure volume on temperature pressure relation in adiabatic reversible process. Hope you have understood. Thank you.